All right, today we're looking at how to factor quadratic expressions. I'm so excited. This is when things start to get a little more interesting. In our previous lesson, we looked at how we could multiply polynomials together. Maybe you could multiply two polynomials and get a quadratic. Here we want to go in the other direction. We want to factor a quadratic and get those polynomials back out again, okay, those two factors. So let me give you something we can start out with, something not too hard. What about some kind of expression like x squared plus 5x, okay? Can I factor this, right? Yes, I can. Notice there is a common factor in each of these terms that I can take out. I can sort of think of this as a kind of x times x plus 5 times x, right? This is another way of thinking about it. And so very clearly, I have a common factor of x that I can sort of take out. I can factor out of both of these. And so if I do that, I factor an x out of both of those two terms, I'm going to get x times x plus 5, right? This is what the factored form of this quadratic is going to be. That is not so hard. We can get it. And that's what we learned sort of how to do last time. Now, if I was to take this expression, what if I made it just a little bit more complicated and I said it was x squared plus 5x plus 6, okay? Just add a 6 over there. Now the question is, can I factor that, right? Could I break this into sort of two factors that multiply together and give me this expression? Well, the problem is there's no single common factor here, right? There's no x here in the 6, and so I can't factor that out. I'm kind of stuck. It kind of seems like this is impossible, right? If I was to try and get some kind of factored form where I had some number here, or some factor times some a plus b plus c, well, it does seem like this is impossible, and I cannot factor this expression. But that's not completely true, right? So in this case, I was able to factor this binomial into a monomial times a binomial. This is a trinomial. I've got 3 terms. I'm not able to factor that into a monomial times a trinomial. But if we remember multiplying 2 binomials to get a trinomial, there might be another way to do this. So let's look at an example here. What if we were looking in the past at multiplying x plus 5 times x plus 6, right? If I do this, I FOIL, right? So if I FOIL this, I'm going to get x squared plus 6x plus 5x plus 5 times 6 is 30, okay? Remember, this is our FOIL method. So first times first, x times x, right? Then outer times outer, so x times 6. Then we're going to have inner times inner, so that's going to be 5 times x. And then finally, we're going to have last times last. So that's just our 5 times 6 gives us 30. We FOIL it out. And from here, what can we do? Well, we can simplify. So this becomes then x squared plus 11x plus 30, right? And it's very clear where this came from. The 30 came from here, the x squared came from here, and this 11 was the sum of these two together, right? We added those together to get 11. So if we were to start with this trinomial and ask, can I factor this? The answer is clearly yes, I can factor it into x plus 5 times x plus 6. I can factor it into the product of 2 binomials, 2 linear polynomials. And that is a way that we might be able to factor this expression right here. Okay, so let's take this expression and see if we can sort of apply the same logic, go backwards using sort of reverse foiling is essentially what we're trying to do here. Okay, so I'm saying if I can factor this, it should probably wind up being some form of some x plus, let's say, r plus some kind of x plus s, okay? So I don't know what r and s are, that's what I have to find. But I think this should be the form it would be in, right? Sort of the product of 2 binomials. And what we want to do is we want to see what is the relationship between r and s. How are those related to this original expression? So what happens is we can see that this last number, this 30, is last times last, right? 5 times 6. So r times s should equal 30, right? R times S should equal 30. Oh, but in this case, sorry, in this case, we're looking at this one. So R times S should equal 6 in our case, okay? R, that's last times last should give us this term. But this term over here, this 5, is produced from the sum of these two middle terms. And so basically, R plus S should equal 5. Okay, that's what we have here. R plus S, this should equal 5. Okay, and so these are sort of the conditions that we have for R and for S. And what we've essentially done is we've created a system of two equations with two unknowns. So we should be able to solve for R and we should be able to solve for S. Now, there's different ways you could solve for this, but we're just going to think about, well, what are the factors of 6? 1 times 6. Okay, that's one set of factors. Another set of factors we have for 6 is 2 times 3. Okay, 2 times 3 is another set of factors. But we're saying that these two factors added together should equal 5. Well, 1 plus 6 equals 7, so that doesn't work, but 2 plus 3 does work. 2 plus 3 equals 5. And so this must be the factors that we're going to use here for R and for S. And so what I'm saying is that we should be able to break this down into some x plus 2 times an x plus 3 as the values for R and S. And if we were to FOIL this out, what would we get? Well, we would get x squared plus 3x plus 2x plus 6. And x squared, this becomes 3 plus 2 is 5x plus 6. So that works, right? This actually works. This is actually what we're going to get for the factored form of this original expression right there. We can factor it out into two binomials. That is the key here. And the process is to recognize that these two numbers are going to multiply to form this 6, and they're going to add together to form this 5. And that's the key to solving this. So let's try another example here. Here we go. We've got x squared plus 11x plus 24. Okay, so for this, we want to, again, think about sort of these two numbers right over there. What I'm going to say is we're going to try and find the factors of 24. So two numbers that multiply together to create a 24. And they add up together to create an 11. And I'm just going to make a little bit of a table here of some potential values. So what are the factors of 24 going to be? Well, we could have 1 and 24, right? Those are pair factors, right? We could have 2 and 12. We could have 3 and 8. We could have 4 and 6. And we go to 5, nothing. 6 brings us back, right? If we go up to 6, we're just repeating these, but in reversed order. So this is it. This is a table of all of the potential factors of 24. They need to add up to give us this 11. Okay, so does 1 plus 24 equal 11? No, that's 25. Okay, so that doesn't work. Does 2 plus 12 work? Well, that's going to be 14. No, that doesn't work. Does 3 plus 8 work? Yeah. That's 11. Okay, so that's telling us that we should be using 3 and 8 for the actual numbers as R and S in our binomial product of factors here. Okay, so let's write this down. What we're saying is we expect this should equal x plus 3 times x plus 8. And this should be the factored form of our original expression. And let's test it. Okay, if we FOIL this, what do we get? We get x squared plus 8x plus 3x plus 8 times 3 is 24. Simplifying that is x squared plus 11x plus 24. Sure enough, it works. And we have successfully factored this quadratic expression that might have looked impossible just a few minutes ago. All right, let's take a look at how we can develop this further. What I want to consider now are negative signs and how this might impact how we factor our quadratic expressions here. Notice this one, everything is positive, should be no problem, but in this one we have a negative sign where before we had a positive sign. So let's see how that changes things. Well, first of all, let's just factor this one. Everything's positive, it should be fine. So remember, we want 8 to be the product of the two numbers there. So 8 is the product and they should add up to equal 6. Okay, so let's think about what the factors are going to be here of 8. The factors of 8 are 1 and 8, 2 and 4, 3 is not, 4 is, but then you're just repeating. So that's it. These are all the factors we're going to have. Now 1 plus 8 is 9. That's not going to be 6. 2 plus 4 is 6. That is 6. Okay, so that should be it. These should be our numbers that we're using here. The terms in our factor should be x plus 2 times x plus 4. If you do the foiling, you should verify that this does in fact work. Okay, let's try the next one. So once again, we have an 8 here, and now we have a negative 6. Okay, so what we're saying is that we want the product of our factors to equal 8, but we want the sum to equal negative 6. Okay, now this is going to be a little bit interesting. So before we saw we had factors of 8 are 1 and 8, 2 and 4, but 1 plus 8 is positive 9, 2 plus 4 is positive 6. Neither of these is going to give us negative 6. Looks like we're stuck. What do we do? Well, we overlooked some factors of 8. In fact, 8 can also be formed by multiplying negative 1 and negative 8. Also negative 2 and negative 4. So there's actually 2 extra possible factors here that we have to consider. Now negative 1 times plus negative 8 will give us negative 9. That's not what we want. But negative 2 plus negative 4, this will give us negative 6. This is what we want. Okay, so that's telling us that our factors here should be x minus 2 times x minus 4. And that's actually going to be our final answer here. If you multiply these together, you FOIL them, you should get back x squared minus 6x plus 8. Okay, so we can work with negative signs in this position. Just notice what's happening here. So there's sort of our general rule here that I'm going to introduce. So in general, if we write down our quadratic here, some x squared plus bx plus c, then while this c value is positive, right, for all positive c, then notice in our factors, these two numbers are going to have the same sign. Same sign here. These are both negative. These are both positive. Okay, now they're both going to be positive if b is greater than 0, right? If this number is positive, then both of these will be positive. But if this number is negative, then both of these numbers here will also be negative. So that's sort of how the signs get controlled here, right? Let's look at another way negative numbers can impact how we factor things. Here, notice that both of these will have a negative c value, but once again, the b value alternates. One is positive and one is negative. Let's see what impact this is going to have. So let's factor this first expression. We want the product here to equal 8 and the sum to equal 2. Okay, so this is what we're going to start out with. What are the possible factors of negative 8? Well, we have negative 1 and 8. Negative 2 and 4, but also we have 1 and negative 8 and 2 and negative 4. Okay, so we have to consider all of the options here. But to get a negative number, one of the factors must be negative and one of them must be positive. We must have opposite signs here. Okay, so let's go through this. 8 and negative 1, that's going to give us a positive 7, so that's not 2. Negative 2 plus 4 is 2, so that's actually as far as we need to go. That's going to be our answer. Our answer here should be x minus 2 times x plus 4. And that's it, right? That's going to be our factored form for this quadratic expression. Let's do the same thing over here. Well, here we have, again, a negative 8, and here we have a negative 2. So the factors of negative 8 are all going to be the same. Okay, so I'm just going to drag this over. This is going to be very similar. However, this is now a negative 2. Okay, so now the sum of these first two is going to be positive, so it's not going to be either of these. 1 and a negative 8 will be negative 7. That's not negative 2. 2 plus negative 4, that is negative 2, so that's going to be our answer here. We'll get then x plus 2 times x minus 4, and that will be our final answer for the factored form here. Now, what's going on here? I want you to notice something. Previously, our c values were positive. So when the c values were positive, then our factored terms here are all going to have the same sign, either both positive or both negative, because multiplying two positives gives you a positive number, and multiplying two negatives also gives you a positive number. But here, it's different. Because c is negative, our two terms here, the numbers here must be opposite signs. That's the only way they can multiply together to give us a negative number. All right, so that's the first thing. If this number is positive, then that tells us the larger absolute value of this number must be bigger than this one, right? Because you want the positive plus the negative to give you a positive. That means the positive number must be bigger. If this b value here is negative, that's telling us the larger valued here, the larger absolute value here for this number must be bigger than the positive one, because you want the negative plus the positive to still be negative, okay? So that's sort of the whole pattern that we're working with here. And you can write this down in a kind of general rule just like this, right? So when this is negative, you're going to have opposite signs on the two terms here. And if this number is positive, then the bigger number here is positive. If this is negative, then the bigger number is negative. Okay, that's the idea. So that shows you what happens if we have negative signs. I kind of didn't write an example if you have a negative sign here in front of the x squared, because I don't like to think about what happens. It kind of reverses everything. My point of view is that if you have a negative sign here, what you should do is just factor out a -1 from the entire polynomial expression and convert that into essentially a positive sign. So here's sort of how we can think about that. What if I have something like this? Okay, I have a negative sign here. Well, if this negative sign is here, what I can do is I can factor out a -1 from this entire expression, and this is what I'll get. I convert this into a positive number, right? And now I just have to factor this expression, right? So that's the idea, right? I want to convert that what we might call an a value from negative to positive by factoring out that -1. And now this is easy to factor. We just did this, right? This is going to be -1 times, well, this is the same as this. So this is going to be times x plus 2 times x minus 4. And if you want to, you could multiply, you could distribute that -1 into one of these terms. So you can get a -x minus 2 times x minus 4. And that would also work. Okay, that's another acceptable way of factoring that kind of expression. So when there's a negative sign in front of here, factor a -1 out of everything and then just treat it as if it's positive. You'll just have an extra -1 factor at the end. And that is how we can solve relatively simple quadratic expressions like the ones we looked at today, of the form x squared plus bx plus c, where b and c could be either positive or negative. And in fact, we also looked at the example where x squared could be a negative x squared. However, we did not look at the possibility where the coefficient in front of x squared was not 1. That requires a more general type of solution and more general type of solving these kinds of quadratic expressions that we will look at in our next video. So I hope to see you there.